So in the middle of our F8N Project 4, I came across a problem with my welder. So I'll just let you listen. When I click on the button, nothing happens. So that could mean multiple things. That could mean that there's an issue with my welder that I need to investigate. That could mean that my wire here is clogged up somehow and pinched somewhere that I would have to go and investigate. And probably the most simplest thing is that I may be out of wire. So I figured I'd use this time to make a video on the welder and kind of how I will resolve this issue. Before we get going here, I just want to say that this is a very basic video on the MIG welder here and how to change out the gas in the wire and get it set up. And I know a lot of people out there don't need this type of information, but I know that there's a lot of people out there that do. So I thought it was worth to take the time and do an in-depth review over the welder and exactly how to change out the gas and the wire, and give a little bit more explanation on the MIG gun itself. So if you're a welder, this may be a bit boring to you, or you may learn some tricks that you never thought of. There is an awful lot of need out there for basic shop information. So when I'm working in the shop, I try and think about those who may be new to the business, who are just getting into it, and don't even know the difference between a MIG welder, a TIG welder, a stick welder. And so for those people out there, they need these type of in-depth reviews. So this is going to be long and tedious, but for those of you who need it, I hope you like it. Just to recap on my welder, I have a Miller-Matic 252 welder. So I'm a fan of the Miller product, the Miller brand. I've used a lot of Lincoln welders as well, and they're great. But I personally am a fan of the Miller products. You have a lot of other good brands out there. Some of them are more industrial. They're a little bit more expensive and a little bit out of my price range. And they're good welders too, but for me, the most bang for your buck is in the Miller equipment. I feel that some of the Lincoln equipment, they have a lot of good industrial equipment, but then they are also sold in the big box stores. And anytime a name brand gets put into the big box stores, their quality usually dramatically drops off, at least for those specific items that are sold in the big box stores. You're not going to find a Miller in a Home Depot, so I can say that about them. You're going to have to go to a welding gas and supply or order off a welding site online to get Miller products. And that's the same thing with a lot of the other industrial welders as well. So again, here's my welding gun. When I press here, you can see nothing is happening here. So I'll go over to my welder, and what you notice is whenever I press the gun, I'm still getting an actuation sound coming out of the gun. So that leads me to believe that the welder is working properly. So the first thing I do is I'll open up the side panel here. And the first thing I notice is I'm out of wire. So, you know, that always sucks when you're halfway into a job and you're out of wire. So I'll show you here again what's going on. When I press the button here, you can see these gears moving. So that all looks good. And another thing I notice is I'm not hearing much gas flow coming out of this. So I do have some gas left in the tank. So this is how much is going to the gun. Right now it's set at about 25 or 30 CFH. And then this is how much is in the bottle. And you can see that's pretty low. So let's see if I got some gas going through the nozzle here. Yep. So you hear it, it'll come on, and then you'll hear a delay. So the delay is to shield the wire. After you stop the welding, you want to go ahead and shield that wire until it actually cools down for just a second or two. So since I'm going to make a trip to the weld supply anyways to grab some wire, I might as well go ahead and refill this tank. So when you're going to replace a roll of wire on a miller, it's fairly easy. You've got this cap here. You just squeeze these two pins, pull out, and then pull the wire off. So there it is. And you can throw these things away, but you never know when you might need something like this. This looks like it could be a neat little arts and crafts piece, so I might hang on to it because I could use it one of these days. We'll see. You'll also know there's this spring in here, and what the spring is for is if you get a smaller roll of wire, you use this spring to create the tension to keep it up against this back plate. And if you notice this back plate here, it has this little nipple here, and that's to grab the wire to make sure that it spins properly, and so that the roll is not just floating here in midair. And this spring, if you have a smaller roll, will push the roll up against this pin here. So we got our gas bottle here. We want to make sure that it's properly closed all the way. That's closed. Another thing you want to do is you want to deplete the gas, because there's going to be gas in this line here, and you can see right here we're still at about 30 CFH. In order to deplete that, you want to press the trigger on the gun. So here I've got the gun. You can see the gas that's left in the line, and watch this needle drop as I press the gun. So there it is, completely dropped off. Next, I have to remove the connections. So you have this connection here that goes to the back of the welder, and that feeds into a solenoid that shuts the gas off and on as you press the gun. And then you've got this connection here that feeds into the bottle. Typically, I only take this connection off. It's the only one you need to take off, unless you're going to be transporting the welder to a new location, or it's going to be on and off of a truck or something like that. I usually wouldn't mess with this connection here. So to get this connection off, I'm going to use a crescent wrench. Ideally, you want to use a wrench that's made for these bottles, some type of a bottle wrench, or an actual wrench that's made for this size, but I've always just used a crescent wrench and I've never had an issue. You just want to be careful that you don't strip out the edges over here. So I've got my crescent wrench here. You want to be very careful whenever you break this loose, because if there was any residual air left in here, when you break this off, it's going to shoot out. Whenever you break this loose, you want to do it slowly. That way, if you did forget to shut this off, it would bleed the air off, and the continual bleeding of the gas would let you know that you didn't shut the bottle off. All right, that's it. Okay, the next thing you want to do, you got the bottle shut off, you got the gauge taken off. The next thing you want to do is make sure that you cap the bottle. You want to cap the bottle before you ever remove it, or before you ever take it off the welder, or if you're ever moving a bottle around the shop. You always want to make sure that the cap is on here. So we've all heard horror stories of these bottles falling and the valve getting snapped off. And when that happens, this becomes a rocket. It launches through and it'll bust through just about anything that's in its way. I have a story of a real life event that actually happened to my brother-in-law, much on a welder like this. So whenever you're removing this from the welder, you don't think, you think you're going to move it from here to the floor. It's not that big of a deal. Well, he actually was in the process of just transporting the welder across the shop, and it didn't have the safety chain for whatever reason. It either wasn't on there or it fell off. But when that happened, this welder tipped back and it snapped the valve off of the top. And when it tipped back, the welder was in the right direction where the bottom was up against the welder. And so it pretty much shot through the welder and then shot across the shop. And he was probably about no more than 10 feet away from the welder when that happened. Had he been directly in front of the welder, it probably would have hurt him pretty bad, if not killed him. But luckily he was off to the side of the welder. The bottle shot through, it completely destroyed the welder, and then I think it actually ended up stopping at the wall, which was pretty far down the shop. So that's a real life incident that I know of. So that really opens my eyes a little bit, because somebody that I knew actually had this happen to him, versus just hearing about the stories of people that this has happened to. So I just want you to be very cautious anytime you're dealing with a bottle like this, and just understand the power that these things really do have. There is a safety chain here, and I'll show you. I generally like to wrap my power cord around the bottle as well, and there's a couple reasons for this. One, it gets the power cord out of my way, it gets it off the floor, and I generally only keep just the amount of cord that I need left off. The other reason why is you've got this dinky little safety chain here, and it does the job. I've never had a problem, but it is a fairly light chain. It's attached to some plate here, and I mean, worst case scenario, this thing could snap off or pop off of this groove inside here, and it could fall back, which is what I suspect probably happened to my brother-in-law there. But I also keep this wrapped around it because it also gives it some added protection so that it doesn't go anywhere. I wouldn't mind taking up another project, a shop project, and coming in here and beefing this up and actually putting some type of a clamp style bottle holder on this. That might be something I do down the road, but like I said, I've never had an issue with this. I just think it's a bit flimsy. Okay, first thing you want to do is you want to make sure the power is shut off. So I've got the power off on it. Next thing, once the power's off, you want to disconnect the cord and then unravel the cord around the bottle. Now you can see how long this cord is and how much of a pain this thing can be if it gets in your way too much. I usually set this on top of the welder or even inside the welder. You want to be very careful that you don't accidentally grab this or trip over this wire and drop that gauge on the floor. They're very delicate. If you drop it, you could mess up some of the very small parts that are in the gauge, and you'll have to have it repaired. Okay, when I remove this, I generally just rock it, make sure it's loose, and then I give it a great big bear hug and just step it down to the ground. just like that. And then when I move this around the shop, you tip it on one end and then I'll roll it whatever direction you need to go. When you're rolling this, you got to be very careful though, because a lot of times you tend to use the cap to roll it with, and if this cap is broke loose, when you roll it in the other direction, you'll actually loosen the cap, just like that. So I'll show you again. If I'm rolling this and then I grab it from the cap, I'm actually loosening the cap as I roll it, and that could cause it to drop down and then break that valve off as well. So when I roll it, I typically am cautious about the cap, and I always roll it in a direction that is tightening the cap, like that. So if you roll it in a clockwise direction, you'll be tightening the cap. If you roll it in a counterclockwise direction, you'll be loosening the cap. Okay, whenever I load a bottle on the truck, I like to keep it about a foot away from the tailgate here. That gives me room to lay it over. Another thing that I do is I always put the valve towards the cab of the truck. And the reason why I do that is because worst case scenario, if something ever happened, if somebody rear-ended me and it caused this valve to break off, it would actually shoot towards the person that rear-ended me, and not actually through the cab of my truck hitting me. So just an extra precaution that I take. Again, that the outcome of that is not going to benefit anybody. It's a bad outcome either way, but at least it'd be an outcome I'd be able to live to tell versus the other person. So I'm always very particular about how my bottles lay in the cab of the truck, and that's with the valve towards the cab, just for worst case scenario. So whenever I get this in the truck, I tip it over, and then I'll actually lift it from the bottom and then slide it in. So just like that, you want to make sure that this is going to clear the tailgate whenever I raise it. The next thing you want to do is you want to strap this down. You don't want this bottle flopping around all over the back of your tailgate. Again, you're posing a risk of this busting that valve off with this rolling around. Another thing is I put this bottle in here a very specific way. If it's rolling around, you're posing the risk of it shifting or rotating, and then who knows where it can go. So when you strap this down, there's a couple ways you can do it. You can just go straight over, strap it down, and it'll hold it down pretty tight. The good thing about a pickup is it's got these ribs in here, and it'll keep it from bouncing around. If you're going to be putting it on a flat surface, you might want to get a block of wood and shove it under here to keep it from rolling back and forth, because even though you've got pressure on this, it could still roll around in here. Another option, which is probably more of a preferred option, is to wrap the strap around the bottle. And so how you do that is you'll come over the top, you'll lift the bottle up, and you'll put the strap underneath it. Just like that there. Then you'll take this in and you'll hook it in. Then you'll pull the slack out of it. Once you get the slack out of it, you'll hook the other end. You can see here I'm wrenching this down. And that's pretty good. And now with this wrapped around, it prevents it from actually rolling around the back of the bed. And you can see with this strap on top, if it just went straight across, you could allow it to roll back and forth as well. See you in a bit. This is my bottle of shielding gas. It is a 75-25 mix, and that is comprised of 75% argon and 25% of carbon dioxide. There's a label right here that shows you 75% argon, 25% carbon dioxide. Another thing on these bottles is they will have a testing date stamped on them that says that they were tested and that they are good. And they will usually have the owner right here stamped on the neck. If it's a personal bottle, you may not have this on here. If it's a personal bottle, it may still have it on here from the company that you purchased it from. And again, I'm going to do a bear hug on it and just lift it right in place. Okay, now that I have it in place, what I do is I'll take off the cap. And the reason why I do that is because I want to position the valve stem in a certain order. Now you can see how my valve stem is oriented here, and whenever you put this gauge on it, I like my faces to be facing towards me and not away from me. And so I mock that up, and then I make sure that my bottle is oriented in the direction that I want it. Once I have that in place, I put my safety chain on. After I got my safety chain on, I will wrap my extension cord, just like that. Okay, after I have the extension cord on, it's time to install the gauge. Before you install the gauge, you want to get your safety glasses on. and you want to clear out this connection here. And how you clear that out is by opening the valve slightly, blow some air out of it, and then shutting the valve back off. You want to be sure you're standing behind the connection and not in front of it. Alright, I have cleared the connection. I'll make sure that my threads are clean and free of debris. Once it's hand tight, then I use my crescent wrench. Now, before I open the valve, I want to back this out all the way until I don't feel any more pressure on this handle. Then you want to stay clear of the gauge, and whenever you turn it on. When you turn it on, if this gauge malfunctioned, it could shoot things out of the gauge. So you want to stay clear of it before you turn it on. Now that I've turned it on, I want to check for any leaks. I want to listen if there's any leaks around any of the connections here and at the bottom where it's connected to the back of the welder. Another thing you could do is you could use a soapy water and you could spray this down. Sometimes a leak can be so minute that you can't hear it and you can't see it. But if you have your gauge up and you shut your bottle off, and you come back the next day and your gauge has now lost some air, some gas, then you know you have a slight leak. And that would be a time when you might use soapy water to find that slight leak. Every little bit of gas counts, and it all costs you money at the end of the day. So if you're losing it by accident, by a very slow leak, that's going to cost you money. And worst case scenario, if you forget to turn your bottle off at the end of the day, it will drain your bottle, and when you come back in the morning, you have an empty bottle. I've done that a time or two. It's not very much fun. Not only does it cost you the money, but then it costs you the time to take the bottle back and exchange it. So now once you have your bottle open, you look at this gauge and it shows you how full your bottle is. And so I have a full bottle right here. On this side, this is the pressure that's going to your line, which goes to your welder. This is typically about between 20 and 30 CFH. And so what I want to do is slowly bump this up to about 25 is where I'll go. So that's 25 there. So now we're ready to go with the gas. And the last step is to turn your welder on and purge the system. So when I open a box of wire, I want to cut around the label. And I'll show you why here just in a second. Okay, I've got my label here. And the reason why I cut the label out is because I go through a lot of wire, I test different wires, and I don't always remember which one I used. And just like this row, I had a hard time remembering exactly which wire I had in here last time, and I threw the box away. So I make it a practice to keep these labels, and I keep it just right here in my welder. That way, whenever I open up this welder, I know exactly what kind of wire's in it, and I can read everything about it in here. Another thing is if somebody else is working in my shop, if you have a specialized job, or especially if you're doing code welding and you have to know exactly what kind of wire you're working with, you want to know all the information about it. And so this stays right here in the welder, and at all times if I switch the wire out, for instance, if I'm going to be welding stainless steel and I want to put a stainless steel wire in there, or if I'm going to be welding aluminum and I want to put a aluminum roll of wire in there, I would then keep the label with the roll at all times. So here's your wire roll. You can see there's not much to it. Some of them will have a cardboard roll, and they may have a sticker on it with some information. But you can see here, you've got a warning label. And it looks like you have this information sticker here. And it really doesn't tell you much. It tells you the wire, the type, the size, the pound, and it does have the ER70S6 there. But how long do you think this is going to last in the shop? So that's a pretty worthless tag there. That's not going to last too long in a shop environment. So that's why I like to keep the label in here. Okay, so now we're ready to install this on in the welder. One thing you want to be sure of is the orientation of the wire. So when you have your wire roll on here, the wire could come underneath, and if the wire came underneath, you can see it would have to have an unnatural curve to feed into the wire feeder. So you want to make sure that your wire roll, the wire loops off from the top, and so that it has a natural feed. And so this is actually backwards. I have to turn it around and then install it. You can see that little nipple right there. It will catch the roll and ensure that the roll spins in the right direction. It doesn't just spin on this shaft here. Now that we have our roll of wire in the welder, we have it in the right orientation, we have our label cut off and inside of the welder for future reference. Now it's time to feed the wire into the wire feeder. So first thing we want to do is we want to untie the wire from the side here and then clip off the crimped end. Once we clip off the crimped end, we then want to fit the wire into the wire feeder. Let me talk a little bit about the wire feeder here. This is a single drive rolled wire feeder, and what that means is that you have two wire feeder guide rolls, and for your more industrial type welders you would have 4. And so what happens is these two drive rolls press together and grab the wire and feed it right back into here, which is what goes into the gun. That's the back end of the MIG welder gun. You know what, I'll just go ahead and show you how that part gets installed, just for those of you that don't know. So you have this knob here which will tighten and loosen the gun. So you loosen that up, and then on the other end you can pull the gun, just give it a little wiggle, pull the gun out just like that. So you can see there's still a little bit of wire left in there. It's that last little bit that the drive rolls couldn't grab onto. So that's where the wire goes into, and that comes out the front of the gun. And then you have this connector here that connects the pins in there. I think there's about 3 or 4 pins in that, which is how the gun talks to the MIG welder. One more thing you might be wondering is, how does this get gas to it? So as you can see, there are no connections for a gas line, but if you look on here, you can see the 2 rubber gaskets, and in between that you can see an orifice there. And what that is that is the inlet for the gas supply, and the 2 rubber gaskets there hold the gas internally from escaping outside of this nozzle here. And on the inside, it's very difficult to see, but that holder right there has a port. I don't know if you can see it, but if you go inside here and where this welder connects to, you can see a little hole right in there, and that's the port. That's the outlet for the gas to go into the gun. And so that's how it works, which is pretty nice, because you don't have a separate connection to apply gas to the nozzle. It's all in one connection, your wire feed and your gas. So we'll just install this back in here, and it just goes right up in there like so. You want to make sure you get it all the way in there and get those rings sealed properly in the right location. Then you just want to tighten the knob up. And it's good to go. Now these drive rolls have 2 sides to them, and there are several different types of drive rolls. I'll give you a look at these. You turn these knobs here, and that unlocks them. Okay, I figured it out. So, first thing is you want to unlock the drive rolls, and you do that from here. So I didn't even realize that this was closed in here. But this is how you apply tension to the rolls. So it's probably good to release the tension off the rolls first. There you go. And that should come right out. There it is. So a better look at these rolls. You can buy these individually from Miller or from your gas supply store. And one thing to pay attention here is the type of wire that you're using, and make sure that it matches the rolls here. So you can see engraved in here is 0.035, and that's the diameter of the wire, and 9mm. That's going to be the same on both ends. Now if you turn them around, you can see 0.030, and that's 8mm. And so the side that's facing you, the side that you can read, is the side that you should be using for your wire. Now the type of wire that I have is 0.035, so this would be incorrect if I place this in the welder in this orientation. So I have to be sure to flip these around that say which wire I'm using, which is 0.035. On the side of these rolls, you can see the wire track. So it's got these grooves in here, and that groove is to allow the roll to grab the wire. Is a track so that the wire can roll straight into the welding gun. These things can wear over time, so it's good to do an inspection on them and make sure that they're working properly. If you're having a lot of spatter, if your wire is not feeding properly, this would be a good area to investigate to make sure that your drive rolls aren't worn out. They do have several different style of rolls. You have specialized rolls for such as for aluminum wire, which would have knurls or teeth inside of the roll to help it grab the soft wire. And then your various sizes of wires that you would use. I believe this specific welder will max out at a .045 wire. I'm not certain on that, but I believe that's the highest I've ever seen used on a MIG welder like this. All right, now we'll get the rolls put back in. Okay, again, you want to make sure that your tension is off of the, whoops. I guess you don't want to make sure the tension's off too much, but we'll get that back on there. Since I got it open, we might as well just look at it, I guess. You see in here, we've just got a little spring. Then you've got a little shank there, threaded shank. And got these graduations on this plastic piece here. Alright, we'll get this back together since I'm just tearing everything up. Okay, now we're ready for our drive rolls. Again, I'm using .035 wire, so I need to turn this around in that direction. There we go, then lock it. Now we'll do the bottom one. Let's see, .03, 035 right there. Put that in there, now lock it. There we go. Now I need to get the old wire out of this gun here. So in order to do that, I'm going to use my tool. There are several applications of this style of plier. So you can see that you've got this round area right here, and what that's used for is to grab the nozzle in this area. You've also got your cutting blades right here, and that's used to cut your wire, just like that. And then you've got these this long nose here, and that can be used for various things. What I use it for mostly is pulling out the crud out of the tip of this nozzle here, just like that. You could also use it to straighten out your wire. And then the last piece is this center cutout right here. And what I use that for is to take out the nozzle on the inside. So this gun is a little bit different style because the nozzle here actually screws in. In other styles, the nozzle does not screw in. It just clamps on. It's got a tight fit, and whenever you take it off, then the actual nozzle here will so it's kind of stuck inside there. Try and get it out. There you go. There's another application for it right there. So the difference in this gun here is that this has got a beveled edge on it, and it's not actually threaded. Most MIG welders, this piece right here would be threaded on. right in this area. And so this would get threaded on, and then you want to use this portion to take it off, to grab a hold of here and to take that off. But now you want to pull this wire out, but first you have to make sure that your line is straight. You want to pull this out and straighten it out all the way. So once that's straight, then you want to pull the wire out. Here's my wire. Pull it out like so. So you can see how much wire we end up with here. If anybody knows a good application of this wire here, let me know, because I really hate wasting all this good wire. But I also don't want to be a hoarder either, so if I don't have a good reason to keep it, then I just have to toss it. So there you go. That's your waste from the end of your roll there. Now that we've got all these parts off, I want to make sure that they get cleaned. I want to take all the slag off this tip here. Sometimes I even take a file and grind it a little bit. Just put a fresh new tip on there. These are replaceable, so you can buy more of these. I usually try and make one last as long as I can. If I'm starting a brand new job or something and I've got some critical welds I have to do, I may replace this and start fresh. But if I'm just doing shop projects, I usually try and get the most life out of a tip that I can. Then you want to get all the slag out of this nozzle here. This nozzle is also replaceable. Just about everything on these guns are replaceable. And I might put a file on the end of this too. There you go, got a fresh tip and a fresh nozzle ready to go. So now that I've still got the end of this off, I want to take the time to load my wire so that the nozzle doesn't get in the way of the wire flowing through. Now that I have my wire here, I want to clip the end of this to make it straight. Okay, now that I've got a straight piece of wire, I want to roll it up to the wire feeder. And right in here, you have a guideway for the wire to go into. So you just put that right in there. The wire will come out through the other end. And you want to make sure that lines up right inside that nozzle. You want that to go right in the tip of that nozzle. If you don't get it right in there, when you press the power button on the welder, this will create a bird's nest in here, and you don't want that problem. It may be difficult to get out. So you just want to run that right in the nozzle. Run that in there a couple inches. And then you want to make sure that this line is right on the guide track, and then you want to close the top roller on it. Also, you want to make sure when you close this, you've got some teeth back here, some gears. You want to make sure that these gears mesh properly. If you get a tooth on top of a tooth, it won't close all the way. Okay, we have it closed. Put some tension on it. And check here. And we've got pressure. That means that I'm properly grabbing my wire there. We've got the roll on. It's feeding in the right direction. We've got it in the wire feeder. We've got our tension on. We've got our drive rolls in the right orientation. Our gun is tightened here. I think we're ready to close this up and finish on the other end. Okay, now that we've got our wire set up, we want to do our drive speed here, wire speed, and turn that all the way up. Now we want to press the trigger until the wire comes out about 5 inches or so. Okay, now we've got our wire out. We've got a fresh clean cut on the end. We can put our tip on. We slide our tip on just like that. Make sure it's recessed in this nozzle. Now it's time to put the nozzle on. Again, this style is threaded on, it's not pressed on. So it goes on just like that, and then we thread it on. Then we want to clip the wire off the end here. You want about 1 inch to a 1/2 inch stick out here. Another good application of this tool is if you have the wire cutter facing towards the outside, it gives you a good reference point. If you just put this end faced up with the nozzle, you clip, it gives you a good stick out at the end of your nozzle. Now we are ready to weld, and that is a very long and thorough explanation of how to set this welder up. Okay, I want to take a minute to talk about my welding gun here. This gun here is an aftermarket gun. It is a Bernard, I believe it's a Q300 model. And it actually has the model number written right here. Looks like Bernard QT3-45. So that may actually be a QT300. And what that means is that with this gun, you could weld 300 amps no problem without overheating or destroying the gun or hurting the life of the gun. It's been a really good gun for me, and Bernard actually makes all of the Miller MIG guns that come standard with their MIG welders. I do have the other standard gun here, and I'll show you. I haven't even taken it out of the box. So here it is, and you can see it looks very similar. The end here looks very similar to the Bernard. And then you've got this gun right here. You got the trigger. And I'll show you how this nozzle works. This nozzle here just pulls off like so. It's not threaded. There's no tip in here, but you can see inside here it's got a threaded area for the tip to be threaded in. And if you look at the size of the gun, a little bit difference in size. Not a whole lot, but you can see the size is a little bit different. You can see the angle of the gun is a little bit different. You can actually take off the top of this gun and replace it with either a straight tip or a flexible nozzle. and they have several different orientations. This is about a 45 degree. You could possibly get closer to a 90 or 15 degree angle. So these guns are very versatile. They're very strong. They're among the best in the business, and I've never had a problem with it. I've liked it so far very much. With that being said, there's nothing wrong with the standard guns. My last welder I had this gun for several years. I actually broke the trigger portion of it, and I continued to use it for several years after that. These are very good guns. I don't think that these are rated at the 300 amps though. Even though your welder can supply that type of amperage, I think this will be the weak link in the chain. If you try and weld at 300 amps all day, every day, your gun will fail on you and you will end up having to get one of these. All right, well, if we got everything set up, let's weld the bead up and see how she goes. My wire speed's a little fast, so I'm going to turn it down. I'm still just a little fast on the wire speed. All right, I think that's it. Not too bad. I got a nice bead going, consistent flow. You can see the wetting of the weld wire there. That's a good looking bead. I hope you enjoyed watching this video and you wasn't too bored with it. This is very basic stuff for a lot of us. But some people can really use this information. I know I could a long time ago when I first started out. So sometimes you have to think even the most basic things are worth putting time and effort in to help somebody else out. Thanks for watching Fabrication Nation.